Hello everyone, welcome to our webinar. Today we will be showing you a demo with a simple cloud-based IoT application implemented with Clarinox's Wi-Fi and Bluetooth stacks running on Infineon XMC4700 Relax kit interfaced with Clarinox Joeyduino Shield wireless module. Well, first of all, let me give you a brief introduction to Clarinox. As you already heard, Clarinox provide embedded wireless solutions to the customers to build innovative and competitive IoT products. Clarinox's products range from software solutions to a series of interrelated hardware modules. Clarinox participates in the partner programs of the leading companies in the market, including ARM, IER, Intel, NXP, ST Microelectronics, Texas Instruments, etc. So Clarinox has a number of clients spread across various industry sectors. And Clarinox is based in Melbourne, Australia, but we have offices in Chennai and Istanbul as well. Clarinox Wi-Fi and Clarinox Blue are among the major wireless connectivity products that Clarinox provides to their customers. Clarinox Wi-Fi protocol stack is the only stack with WPA enterprise support running on real-time operating systems. It supports access point, station, and Wi-Fi direct, that means point-to-point modes, and also multiple roles simultaneously. Clarinox Blue, on the other hand, Bluetooth protocol stack supports for single mode or dual mode Bluetooth with Bluetooth low energy. It supports multiple simultaneous roles and profiles. And Clarinox Blue provides a simple and flexible solution for the developers, enabling them to spend more time on their application rather than wasting their time on inner working on the Bluetooth technology. So both these protocol stacks support blocking and non-blocking API calls and enable single and multi-threaded applications. Next, we move on to Clarinox Debugger. Debugger is a software tool for debugging embedded applications. I will quickly go through the Clarinox Debugger tool because it will be useful because we are using it during our demo today. So here's the latest version of Clarinox Debugger, and it shows the debug information of the application running on the hardware connected through either UART, Ethernet, or J-Link. The virtual console here is similar to a COM-port serial terminal where you can interact with the application by giving inputs. And when connected to our MQTT application, for example, the top left message details window will show the details of the MQTT messages, and the details are related to the content. And the other two windows you can see on the middle and the right hand side. The SDIO monitor for Wi-Fi related messages and the Clarinox Blue monitor for Bluetooth related messages. It also shows the function traces in the message browser window and how the memory is being used related to Wi-Fi and Bluetooth protocol messages. So this Clarinox Debugger gives you a very detailed status of the embedded application. Under Tools Configuration, we can configure the relevant debugger connection. For example, for our demo today, we are using UART debugging. So I have already configured the COM port number and also the baud rate here. So let's move on to our slides. Well, moving back to our slides, yes, the Clarinox also has a series of hardware that supports our software and the protocol stacks. Starting from the EVMs, the Koala EVM Blue is the first ever multi-vendor platform to support simultaneous Wi-Fi, Bluetooth, and Bluetooth low energy applications. By multi-vendor platform, I meant that the CPU of this EVM is designed to be removable so that it fits with any other vendor CPUs. The EVM consists of a Arduino interface, Ethernet, USB OTG, CAN bus, and micro SD card interface as well. So there are also small wireless modules with a CPU, which are called Joy modules or Qual Connect modules. They are fully functional Bluetooth and Wi-Fi modules with a small form factor, and the customers can use these modules either as prototyping or as the final product. There's also a sensor board as the same size as these Joys, which is designed to be pin compatible with these Joy modules. People can use either Joeyduino carrier or WMI carrier to prototype these tiny Joy modules and the sensor boards. This Joeyduino Shield is Clarinox's Wi-Fi module or Arduino interface, which has Wi-Link 8 radio, which supports simultaneous Bluetooth and Wi-Fi. Well, this is a short summary of Clarinox's products. If you need more information of our products, please visit www.clarinox.com, where you can get more details on these products. Moving on to our demo, I will explain the main hardware modules we are using in this demo. We use Infineon XMC4700 Relax kit, which is in red here, which has the XMC4700F144 ARM Cortex-M4 based microcontroller running at 144 megahertz with 2 megabytes of flash and 352 kilobytes of RAM. So this board has onboard USB debugging, so that we can use the same USB port for both J-Link programming and debugging. We have already programmed our Infineon Relax kit with our IoT application. And another important thing on this Relax kit is it has an Arduino interface. So we are going to use our Clarinox's Joeyduino Shield over this Arduino interface to provide the wireless functionality. So moving back to the Joeyduino Shield, this wireless module has Wi-Link 1831 radio, which enables both Wi-Fi and Bluetooth at the same time, running with multiple roles and profiles simultaneously. So in this demo, we will experience the simultaneous operation of Bluetooth Low Energy, Wi-Fi access point, and station modes running on this module. Well, as I mentioned before, in this demo, we will be showing you a simple cloud-based IoT application implemented with Clarinox Wi-Fi and Bluetooth stacks running on Infineon XMC4700 Relax kit used with Clarinox Joeyduino Shield. So the picture shows you the complete setup of the demo. As you can see in the middle, the Infineon Relax kit and the Joeyduino Shield acts as a Bluetooth IoT gateway with Clarinox Blue stack running in it. So this IoT gateway will send some sensor data in home environment to an Amazon web server so that the data can be accessed remotely via mobile apps. So in the demo, we assume that the Bluetooth gateway hardware is placed in a home environment so that it has access to the BLE-enabled sensors in the kitchen and in the garden. So we use TI Bluetooth Low Energy sensor tags, as you can see in here in red, which have a number of sensors including temperature and light sensors. And the readings of these sensors are used to model kitchen and the garden temperature and the light level. So the first sensor connected to this gateway via Bluetooth Low Energy is considered to be in the garden, while the second sensor connected is considered to be in the kitchen. So that's how we'll simulate the smart home environment in this demo. Initially, the IoT gateway starts with Wi-Fi access point mode. So then we configure it to be connected to the Amazon web servers through the local Wi-Fi network. So this configuration is done through the gateway configuration tool running on a smartphone or any mobile device. Then the hardware setup will restart in Wi-Fi station mode and connect to the local Wi-Fi network as a station. Then it will be connected to the Amazon Web Services via MQTT protocol over TCP/IP. At the same time, the BLE sensors will be paired with the gateway and will be sending the sensor data to the web server. This sensor data will now be accessible remotely over internet. using MQTT-enabled mobile apps. We will be using MQTT-mobile app to connect to Amazon Web Services and access these sensors installed in the garden and the kitchen at our home. So this is the overall idea of the demo setup, and now let's move on to the real demo. Well, on the webcam screen, you can see the hardware setup with Infineon XMC4700 Relax kit, interfaced with Clarinox Joeyduino Shield. And there are also two TI sensor tags, which represent the temperature and the light level in our kitchen and in the garden, as I described in before. So on the left-hand side of this screen, you will see the Android mobile device screen. This mobile device we will use to load the gateway configuration tool and also to run the MQTT- application. To the right of the mobile device, you will see the Clarinox debugger with the virtual console and SDIO monitor turned on. Let me connect the hardware setup to the PC via USB connection. And at the same time, I will also connect the debugger with the hardware setup via UART COM port. As I mentioned before, the UART COM port settings are already configured, so I just have to press this start button to connect the debugger to the hardware. So I'll power up the hardware setup, and at the same time start the UART COM port. And you will see in the debugger virtual console, it enabled the Relax kit and the Joeyduino Shield, our hardware setup, as a access point. So at this time, if I go to my mobile device, Wi-Fi settings, and if I scan for the available Wi-Fi networks, I can see there's an access point named CLX MQTT underscore 9999. So this is our Joeyduino Shield Wi-Fi access point. So we are going to connect to the access point. That means we are actually connected to the Joeyduino Shield wireless module. And you can also see in the virtual console, it says a new device is connected and the IP address is given to the device, which is our mobile phone. Then I'm going to load the gateway configuration tool to configure our gateway device to connect to the Amazon web server. So this is how I do it. I'll open the web browser and type 192.168.1.243, which is an internal web server running on our Joeyduino Shield module. So we first log into this, and then it will load the Clarinox IoT Gateway configuration tool, where we enter the local Wi-Fi network settings and also MQTT Amazon web server settings. So once all the details are entered properly, click on Submit, and it will make this configuration tool to be disappear, and also it will reload the Clarinox debugger because it resets the hardware module. And you can also see it connected to the local network successfully, and also to the MQTT server, it was successfully connected. So before I turn on any TI sensor tags, I will open MQTT dash application on the mobile device, which is this black icon here. So this is the interface that we have created. You can see the garden temperature, garden light level, kitchen temperature, and kitchen light level. So these are the already registered topics on the web server. You can see with these icons. And these four widgets here, garden temperature, light level, and kitchen temperature, light level, these are the values that will be sent by these TI sensor tags. But we haven't turned on the sensor tags yet. So these are the previous values that we had in the server. You can also see there's a garden light here. It is a light in the garden which will turn on when the garden's getting darker. And there are two more topics, home heater and home aircon, so that users can turn on and off the aircon and heater. And another similar icon, garden irrigation, in here. Same as an on-off button. Users can turn on and off garden irrigation by tapping on this widget here, icon. So for example, if I tap on this icon, you will see it turns on, garden irrigation turned on, which is in green. And if I click on again, it will turn off. So if you see carefully the hardware setup, you will see there are two LEDs turning on and off depend on this garden irrigation turning on and off. For example, the left hand side LED will turn on when the garden irrigation is on, and the right hand side LED will turn on when the garden irrigation is off. So both this mobile app and hardware setup is synchronized through the web server. So let me, as also you can see all these changes and the topics are also published in the Clarinox debugger virtual console as well. Let me turn on one of the sensors, and you can also look at the virtual console output when I turn on the sensor. So the sensor is now connected to the gateway via Bluetooth Low Energy, as you can see here. And I mentioned before, the first sensor connected to the gateway is considered to be in the garden. So as you can see in the garden light level and the garden temperature has been changed. So there's garden light, as I mentioned before, which will turn on when the garden's getting darker. So we can simulate this. If I cover this garden sensor, the light level will reduce. When it is reduced below 10 lux, the garden light will turn on. Okay, I'll turn on the other sensor, which represents the kitchen. As you can see, it is now connected. And it will represent the kitchen temperature and kitchen light level. I can verify by covering that sensor as well, and you will see the kitchen light level will reduce. So it is likely in a home setting there are multiple users who need to access the appliances and visualize the sensor data. So this can be simulated when multiple users use the same MQTT dash application, and the changes that they made to the home environment will reflect on everyone else's devices. So it is more convenient and handy. So this is how we demonstrate this simple cloud-based IoT application simulating a smart home environment. So I hope you understood the usage of Clarinox Wi-Fi and Bluetooth protocol stacks in simultaneous roles together with the hardware setup. So that concludes our demo, and I hope you enjoyed it. And thank you very much for watching.